He actually proposed I could do this or that, and we discussed on the Slack group, and we want to bring together people with the same technical.
Just find some place to stop and start it again.
No, the peak of confusion around Kubernetes, around containers, is still happening, but I think this is a really nice technology which you cannot ignore today. So our Slack group, you can join, you can auto-register, and we have a Twitter handle, of course. And today, thank you for our sponsors. So the rooms and the pizza, by the way, was sponsored by Lars and the SRH. And last but not least, thanks for to our speakers. Lars is going to present first on one topic, and Tobias Schwenk from Lotse. He's going to present next. We have a little bit on the details, but before we go into the details, look at this landscape slide. Right? This is so overwhelming with respect. When I presented it last time, it was already overwhelming. It's still getting bigger, right? And there's so many topics. If you want to be a full stack with respect to cloud native developer, you at least got to have information about, or you would need to know about some of the tools in many of these topics. And that's what we're here to try to foster, right? And so therefore, that's what the poll is all about. Just join the generals channel in our Slack group and vote for some of the topics. The interesting point is the CNCF, we're sponsored by the CNCF as well. There's a speaker's office which is administered by the CNCF. So if we don't find people on various topics, we can actually tell them, look, we've got like 200 votes on this topic. Can you sponsor us a speaker? And they'll send someone, right? Might also happen virtually, right? And the next meetup we want to try and do again a virtual meetup. So with that, I think toilets are over there. Refreshments is a €2 self-paid thing this time inside the quick now, but the pizza. Okay, so talk number one. So Lars here has an interesting history around Kubernetes. I think he's done some real production level work for a company in Freiburg.
Yep.
He's going to talk about that probably in detail in his talk. But what we opted for is a ground level topic around storage. So I think the abstract says it all, but the first time you get exposed to Kubernetes, I think when you get a cluster from AWS, Azure, or whatnot, storage and networking is delivered to you as a service. But the moment you want to replicate the same kind of experience in your own premise, on your bare metal systems or whatnot, you have a problem around getting storage in place. And I think that is essentially the talk. Lars is going to help you understand about the container storage interface. And without further ado,
but with a little technical pause.
switch.
Maybe we can also show this Leica poll.
Where's that?
Yeah,
the Stacker poll.
Yeah, we have a poll for the topics that we would like to present in the next meetup. So if you like, you can join the Slack channel, maybe now if you want, and choose the topic that you're interested in. So you see here we have multiple topics. We took them from the landscape that Vasu just showed. So you can just choose one of these or add an option for a topic that you would be interested in. Ideally, this should come from this landscape. So you see here, Pavel voted for serverless and solvable platform. So this means that we're going to look for the next meetup for speakers in this, based on the poll, in this area.
Take three.
Yeah, so please go to the channel, vote, so we know what is your preference. You get priority because people who don't attend don't get this priority. So use this ticket.
Please also use the add option button if you have some other ideas. So those are like just a few things we picked from the map. But if you have some particular topic in mind, just use the add option. It's not like you have to use 1 to 7. Go crazy with it. Yeah. Okay, and with this, if we can do the technical.
Let's do it.
You do the HDMI, right?
Yes.
Okay. Let's get this out. Okay, we can also get this out.
So, let's see. There it is. Okay, so welcome from me as well, again. So topic for today is Kubernetes persistence. So as already said, this is an entry level, and it's with this guy. Who is this guy? I'm Lars, and I'm an IT consultant, and we are consulting on software development, architecture, development practices, and I also have some employees, and we are doing custom software development. So my biggest point, as already mentioned, or my biggest achievement so far in Kubernetes was 18 months with Haufe Lexware in Freiburg, where I started out as an Angular developer and coached the team on Angular development, and then kind of drifted off into their Kubernetes and cloud journey. And what we also do is coaching. Now, since I expect that most of you already know the first 2 points, I wanted to say a little bit about coaching and what coaching actually is. So coaching has been done usually by psychologists, in this case a friend of mine and my wife. And it's for people who would like to change. So if you have a problem, if you have a situation that you can't adapt, or that you feel that you have a problem at work that you can't really solve by yourself because it's always the same problem coming up again, if you have a team who is struggling, or if you have a company and you feel that the general motivation is not good, that your employees are leaving, then that is something where you could have a coach in. So my wife and I have done that already for one company, and essentially I was doing the macro level, so everything from team and motivation, conflict culture, agile development, so how to have a high velocity and so on and so forth, while my wife is doing the personal stuff, so in the individual coaching. So if you have an interest in learning more about that, then just talk to me. So I usually don't do these like self-centered presentations, but since I'm sponsoring the pizza, I was told that it was okay to do so. And because the rooms are sponsored by the SRH Gründerinstitut, I obviously have to talk a bit about them as well. So we are here in the SRH Gründerinstitut. And the SRH is not only the university. This is this blue big tower that you see when you're driving here. And they have a university, actually not one, but I think 7 universities now. And one part of the University of Heidelberg is the SRH Gründerinstitut, which we are here at the moment. It's not only for the students of the SRH, but it's essentially an incubator. So if you have an idea, or if a startup has an idea, or someone just says, okay, I have this crazy idea, but I need some people to do it with, or if you have a company that say, okay, we have this crazy idea, but internally we have so many processes and we do not have the workforce to build this idea, then you can come to the SRH Gründerinstitut. So we have a network of multiple partners. We have a lot of alumni and people that don't go away, like myself and my team. And Yeah, we have also trainings. So for example, design thinking, or as you can see back there, Lego serious play. So it's a lot about creative techniques and how to come to new solutions and so on and so forth. So that's essentially what the SRH Gründeninstitut has to offer. And if you would like to know more or talk to someone about it, there's an open door at November 15th from 2 o'clock until I think 8 o'clock or something like that. So you feel free to join us here, and if you want to know more, then you usually can visit us at this web address, which for some unknown reason currently gives a 403, as I had to find out today. So yeah, so much about our sponsors. Okay, introduction. What's the problem? Well, I had this client. And this client ran one of their main products on NFS. So it was NFS was the storage layer. And the problem that Kubernetes had so far, or still has unfortunately, is that Kubernetes is very good when it comes to compute loads. So you have some application servers that do stuff for you. Kubernetes is the way to go. But if you're asking about, okay, but how about storage? Yeah, chirping in the woods. So it actually was, for most companies, or for a lot of companies, it's quite easy because they run their Kubernetes on some as a service. So they run it on Amazon, they run it on Google, they run it on Microsoft Azure. And all of these providers have their own storage, which is obviously external to Kubernetes. Now, if you are like me and don't really trust as a service providers and don't want to have a vendor lock-in and so on and so forth, then you usually run your own, which is, thanks to tools like kubeadm and other projects, quite easy to do. Me and my team, we've been running Kubernetes for 2.5 years now, I think, or 3 years, starting to get onto 3 years. And so we obviously, and the client, had to deal with this problem. What were our requirements? Well, we wanted to have a free and open source model because I have 2 employees at the moment. So we are not one of those big 3-letter companies that simply buy that solution in. So free and open source. But if we ever wanted to have professional support or wanted to upgrade something, then obviously we don't want to sit on the dead horse. So we need some kind of entity that actually works with it. So company support has to be available, at least in part, or very good community support, which would also be okay. We wanted to have Kubernetes support out of the box, obviously. You don't usually want to write one because that's a daring task. Or is it? Find out later. And we want to have high availability because we want to get rid of the single point of failure. If that wouldn't have been a requirement, then we could just have sticked with NFS or any other solution. The solutions that I looked at were NFS, which is able to run in a high availability setup with another project called DRBD. Then I had to look at Rook. I had a look at Infinite, and I had a look at Heketi. Now, these are the solutions that I will present for now. Right now, there are a lot of more options that are coming our way already. And since, funny enough, like when I posted this Meetup address, I got one private message like within minutes about another open source project that they wanted me to talk about in here. So it's a moving market at the moment. There's a lot happening at the moment. I looked into flex volumes as well. And I will also talk about the future, so the container storage interface. So let's get started. DRBD and NFS HA. Who has ever run an NFS server? Okay, quite some people. Who has ever run an NFS server in a high availability setup? 3 people, and if I would have to guess, 30 plus, right? 50 plus, okay. So the maturity model of NFS is grandpa, right? It has been around since, I don't know, 30 years or something like that. So the project health is, I would say, okay, it's like moderate. I will talk about why I decided like that later. The storage technology is native and it is now running under a company called Linbit. And the complexity in terms of moving parts, in contrast to the other solutions, is actually quite simple. What are the advantages? It is the most mature code base by far. This precedes, I would say, the birth of some people in here at the moment, right? The first versions of NFS. So it's the most mature code base. It has a great documentation. It has a broad community, so it's really easy to find knowledge about people. It's a very easy setup in the end. It has very little complexity, and the overhead for running a lot of different volumes is actually neglectable because everything is running from one central daemon. So this sounds really, really great, but the disadvantages is that the development effectively has stopped. So NFS and the NFS server were originally bought by Sun Microsystems. Then Sun Microsystems was acquired by a company that is currently killing their user base with some licensing stuff. Then it was giving over to Linbit, and since it's been there, okay, there were a little bit of development, but effectively it's not that much happening anymore. It depends on another project called DRBD. DRBD is essentially a replication daemon on the block level that is very old, but that is working quite well. It has some problems with failover. Essentially, if you have if your master is breaking down or has a problem, then your clients obviously have to move over to the slave. This has to be done through a load balancer, and the NFS protocol is not really built in a way that this is supported very well. And the client support is even worse. So it was a little bit hard to do that. Oh, I thought I killed you. Let's kill you again. Also, some handy features that we want to have to achieve our requirements are only available in paid packets, which is not a problem, but it is like it's hard to start with it. So it also has no Kubernetes dynamic storage provider, and that for the time last year when I evaluated all of them was a no-go. So my verdict, well, it's mature, it's simple, it has a few downsides. You can live with it, but it has not really transitioned to the cloud yet, to the cloud journey, so we didn't investigate any further. Next on the block is Infinite. Now Infinite.sh is technically not open source yet, but I still had a look at it. And the reason why I did that is that while the maturity is toddler, so it was born half a year before my son was born, so my second son was born. My second son is now able to walk, and about the same as with this project. The project health is really unclear at the moment, and the reason why I still put that in here is that they made quite the news because they were acquired by Docker Incorporated. And because they were acquired by Docker, well, it is a little bit unclear. I was unsure if I even put them here, because since they've been acquired by Docker in 2016, there were like 2 or 3 news posts and a few commits, but essentially they disappeared since then. So there's nothing more since 2017. Their blog is dead. Communication essentially stopped. Supposedly they are really working hard behind the scenes, but it's really unclear. So on the other hand, since Docker endorses them and Docker is pushing really hard to bring an alternative to Kubernetes, maybe we should have a look at them. But yes, no news, dead block, no public, so they are dead in the water at the moment, so we'll have to wait until they move again. Next up from a contestant is Rook. Now Rook is beta-ish. They are officially alpha, I think, but they have a really good maturity model, and when they say something is beta, then they promise to not have compatibility changes, so you can kind of set on their API. Project health is really healthy. They are working quite a lot, and also public work as well. They're using Ceph, or at least they started with Ceph, but they have moved to a storage framework model. So they are essentially doing something similar that Kubernetes is doing as well. They want to become the storage framework for orchestrators. Why are they one of the top lists? Well, they are a CNCF project. So the Cloud Native Foundation that also is sponsoring part of this event. And well, because one of the other projects of CNCF is our beloved Kubernetes, why we're all here, that's actually something that has quite the advantage. It uses a battle-proven storage by default, which is Ceph. It is now a CNCF sandbox project, and we had the discussion. I think they just set or proposed to graduate to incubation stage. So the CNCF is working it's kind of an incubator. Can you say incubator about that? So it's the Dachorganisation. So it's an organization where projects can come in and then join forces together. And they have 3 different levels. They have the sandbox stage. If a project has gotten enough traction, then they get graduated to the incubation stage. And the 3rd stage, if then again they've proven that they are a good project, then they get to the final stage where they are essentially stable. So the only project, as far as the last time I checked, the only real project that has solved the last stage is Kubernetes. And they are currently trying to get into the 2nd stage. It has multiple storage backends, so the nice thing is you can start with a real simple object store like MinIO or something, and later on, if you see that MinIO doesn't fit the bill anymore, then you can up the ante and go for Ceph or some other storage engine in the future. And it is built specifically for Kubernetes. What are the disadvantages? It's also a very young project. It is still in alpha stage, although some parts are beginning to graduate into beta as well. But the speed in which what they achieved in this very, very little time is enormous. So if you have watched the rise of Docker and how fast they employed and unfortunately also deprecated features in the past, that's essentially when you have a look at the roadmap of Rook, this is essentially what they did. So it's a really awesome project. Back then they weren't, they were with version 0.4 or 0.5, so they weren't even able to upgrade a cluster. They had no real recovery, so a lot of things that are necessary for production use simply weren't available, which is why I unfortunately didn't look into them back then. Well, unfortunately. But if I were to choose one to try out, I would go with Rook, hands down. So verdict, run-up of products, and voted for back then, and evaluated further, is Hiketi with GlusterFS. Hiketi was the best choice back then for the problem space that I presented. It's also a mature project. They are now on version 8 or something like that, but they are pushing out 3 versions a year, so no big deal. Healthy project, uses GlusterFS in the backend, but it is not being endorsed by a company yet. So there are 5 developers who are working quite a lot on the project, on Hiketi itself. But since, well, if you're an open source advocate, you know the problem. It's great to have an open source project, but when you can't feed your family, then you have to make some tough choices. And usually, or at least I hope, that you start feeding your family instead of working on your open source child instead. So yeah, It can change at any time. The complexity itself is moderate. For the moment, at least from what I found, from the solutions page, it's the only major Kubernetes-ready persistence option. And ClusterFS is battle proven. There are petabyte clusters out there at universities, so that's a no-brainer. The setup is quite easy, and it supports both standalone and Kubernetes storage nodes. So you can either have your ClusterFS on specific nodes, so no Kubernetes nodes, but specific your ClusterFS cluster somewhere in the world or in your company, and just use Heketi as the communicator between Kubernetes, your Kubernetes cluster, and your persistence cluster. Or you can run the ClusterFS nodes directly on the same nodes that your Kubernetes nodes are running on. This is, for example, the solution that we at the moment use. The disadvantages. Not entity endorsed, as said. This can get quite problematic in the future. It is strongly opinionated, so it is a lot opinionated, which is like a good but also a bad thing, because either it fits your bill or it doesn't. There is no high availability for the API endpoint. So if your Heketi service goes down, then your cluster is still working. But as soon as you try to deploy a new pod or use storage or change something in the storage, obviously it will fail because the endpoint is not there. And this is quite the problem. So you have to have very good monitoring on there and very good recovery options. Now the point is, but that is essentially the same with Ceph. I unfortunately had one crash where my cluster stopped working due to storage problems. And I can tell you, troubleshooting and recovery of this thing is a real pain in the butt. It is insane. So I think it took me a day to recover everything. And we have a small cluster with 3 nodes. So I'm really glad that I had backups back then, but yeah. Support is community driven. So answer times may vary, your mileage may vary, but yeah. My verdict, it works as advertised until it breaks. I know it's a stupid phrase, but that's essentially how I feel about it, right? It's been running my cluster for like 2 years now, and it worked most of the time. I had one complete crash, one complete fail where I had to rebuild the complete cluster, and I had one other crash that I was able to recover. So for me at the moment, that is still, it still works. I'm not prepared to switch to Rook yet, but I'm very sure that I will in the next half a year, so in the next 6 months. So those are the 4 options that I checked back then. Now, I would like to know who in here is actually running their own self-managed storage. 1, 2, 3-ish. Okay, then it's easy. Could you give us just a small overview about what are you running and what are your experiences with it?
Platform is OpenSeth. For the Ceph cluster. It's stable enough to work with it. It supports a lot of protocols like NFS and so on. But this works well for database and so on. But if you're running like Hadoop sceneries and so on, it's become complicated.
Okay, yeah, I can think.
So on Hadoop you have a distributed file system, and then you're running in a lot of distributed problems and so on and so on. And that is also reasons that I'm here today.
All right, okay, so OpenSeth, and it floats your boat for the moment, but general distributed storage gives a lot of headache. Okay, thank you. You also, I think?
We're actually running a room.
Okay, you're running Rook. Great.
So,
what experiences?
We had a similar experience as you were talking about. When we took a look at Rook, it was very immature. It's like about 1.5 years ago when they just kind of started out and everything was still changing a lot. And I think we regretted it at one point in time. But after that release, we've never regretted that again because it has like really with Ceph underlying super solid storage engine under it, and the API is so straightforward and so great integrated with Kubernetes. Just totally recommend it.
Okay, so Rook, one crash that was really, really hard, and after that it works like a charm since then, and you would recommend it. Okay, perfect. Thanks. And
Yeah.
you.
I don't operate it, but it's Ceph, and we consume it via an open stack layer from SUSE.
Ah, okay.
So it's like an indirect usage.
Yeah.
I think self-hosted storage is also a recursive architecture problem. I guess with Heketi you mentioned one. I have a question back. With Heketi, when I looked at it, must have been a year or so back, they actually replicate the state of what actually is on Gluster, and Heketi keeps their own copy of the world. If there's any mismatch between what is in reality and the internal database of Heketi, that's where you run again in another PETA effect. And that happened to me actually when I was experimenting.
Absolutely. So you're using OpenStack as the layer in between, and then you use Ceph.
Yeah, the Heketi was on bare metal. That was another experiment.
Yeah, okay. So what you said, yes, Heketi actually has their own database, and this database replicates the state for various reasons, which is obviously problematic if you change something under the hood that Heketi doesn't know about. Now there are ways to mitigate that, but you have been just describing essentially the thing where I had to rebuild the whole complete cluster, which is essentially what happened.
Yeah.
So I had one node where a cluster was failing, and the state that Heketi thought the state was in wasn't actually the same. So it started to redeploy topologies and essentially killed one node, which then had the effect that the second node tried to replicate the killed node, and then I was out of options, and yeah. That was essentially one of the problems that I had. But,
so with respect to the community, I asked, this was one of the issues I asked, whether they're going to replicate the state from the actual Heketi store. And it just got closed last week because they're not going to change the architecture. So
great. Yeah, but okay. So Rook is on the horizon, and might be great afterwards. Okay, just a little check with camera guy.
Storage full of your...
What? Storage full? No.
We have to do some merging.
Great. Okay, this is why you're not holding the camera. Okay, thanks. All right. So, then I've just put a topic in here called persistence in Kubernetes. Now, the question for me is, because I didn't put any slides there, because I didn't want to essentially replicate the documentation on introduction to storage. So the question is, how much should we talk about that? Who in here would like to have an introduction to how storage on an introductionary level in Kubernetes works? All right, quite a few. Okay, so then let's
I have a question about the comparison before. You didn't mention the performance and latency of different storage solutions.
Yeah.
Did you know something about that, or is this?
Yeah, we tested them, and with Gluster.fs, I have to lie now to get the points out of my head again. So with Gluster.fs we have different options on how to replicate it. They have actually you can have essentially the rate levels distributed on different machines. And as with rate levels, depending on how many nodes you want to have, how many you want to replicate it, how fast or how many storage, or when you consider a write operation, for example, to be achieved if you want to have, if you want to say, okay, if it's replicated on one node, then it's already okay because it's saved on one node. Or if you want to have the extra security and say, okay, it should be saved on 2 nodes instead, or on 3 nodes, or maybe replicated or distributed or something like that.
Security cost performance.
Yeah,
And
essentially.
scaling as well.
Darf ich sein?
Okay, yes, please. Kommen Sie
Dankeschön.
rein. So. Das ist Neckar Pizza, unser Go-To-Laden, wenn wir mittags etwas essen wollen als Team. Sehr empfehlenswert, ist quasi direkt um die Ecke von dem Polizeihauptquartier. Würdest du es mir gerade da hinten einfach draufstellen?
Dankeschön. Ich bin gerade durch.
Danke dir. Könntest du mir das Ganze einfach da hinten draufstellen auf die Paletten da?
Alles klar.
Danke dir. Okay.
But all of them are on the same level, or is there
No,
one
it is essentially the
rising star?
you do not really get much of a penalty for continuous operations as you do with RAID levels. So essentially you have approximately the same degradation as on RAID levels plus with a network. So for example, if you have a RAID storage and the RAID storage you have a RAID storage. What was it? RAID storage 1 was mirroring, if I remember correctly. So the write operations are about the same from the speed here, minus 5% or something like that. But the read operations.
I mean not RAID level. I mean.
I just want to make
a difference between.
I don't. So, okay. Long story short, I didn't check. I didn't check Rook in particular. I just made the checks with GlassDFS and Teketi. And I saw a decrease of speed of about 5%. But only for continuous reads of big files. If you have short files and you have random access or something like that, then your performance will be degraded severely. So this can go up to like 50 to 60, 70%. This is from the top of my head. It was like 18 months ago or something like that. So bear with me if those numbers is not completely correct. Okay. So let me PD. So a volume essentially, persistence volume. This is a thing that you can save stuff to. Okay. How this is then working in the back end. So if this is actually talking to another server, which is then really doing the storage, or if you're talking to the cloud, where you have some storage or something else, it doesn't really matter. The PV, the volume, is the thing that you actually save stuff on. Okay. Now, if you have your Kubernetes cluster, and you have pods, and you're instantiating this pod, you're creating it. Then you can give it a volume. So the volume is the thing that is mounted in here. These volumes do not talk directly to the persistence volumes up here, but they are talking through an intermediate layer. So when a storage is, or when a pod is created, and you want to have a volume in there, then you're defining or you're requesting, as it is with Kubernetes, you're requesting a certain state. So Kubernetes essentially, from the inner workings, is a kind of a butler. You tell the butler what the state is that you want to have, and the butler will go around and check what he has to do to achieve that state. So for example, if we are saying, okay, we want to have a new pod here, we are actually not pushing Kubernetes into create a pod now, but we are telling Kubernetes the actual state that I want to have is I want to have an instance of this pod running, for example. The same is happening with storage, and what this container does is it creates a so-called claim. So this is a volume claim. It is essentially a way of saying that this pod would like to have a volume with certain properties. For example, it needs to be at least 20 gigabytes. It should be of the class SSD, very fast. It should be, I don't know, distributed. Or it should be, I don't know, some properties that you want to put in there. And what Kubernetes is doing is that it has a list of existing volumes, so persistent storages, and it tries to get one that is matching the properties that are listed in here. So you're getting at minimum the properties that you requested, but you might get more. Okay? So for example, if you want to have a storage of 20 gigabytes, and in the list of volumes that are known to Kubernetes is something that has 50 gigabytes and meets all the other requirements, then it's a match. And then this persistent volume is mounted on the host itself, so on the node that this pod is running on, and then is essentially piggybacked or mounted into the pod itself as the volume. Okay? Everyone with me so far? Okay. I get the double thumbs up, so I think it was correct what I was telling you. Great. Okay. Now, the question is, that's all nice and great. We have added a lot of complexity to this stuff, but how do we get the volumes? Right? I didn't talk about that yet. Welcome to the problem of Kubernetes in the past few years. This is essentially exactly the problem that we are currently talking about. This is why we have all of these different providers popping up. Because there are two ways to get to these. One, you can have these persistent volumes in a dynamic option, or you can have it in static. It's called static. Could be, yeah, probably. Dynamic and let's just call it static. I think it's not correct. My brain is telling me that it's not correct, but this is essentially self-managed. Okay.
Wasn't it manual?
Or manual or something. And dynamic is KHS managed. In other words, this is the type of storage, dynamic, that Kubernetes knows how to create. It has some way of telling whatever storage engine you have put in the backend that you want to have a physical volume, a PB, that has these following properties. And if you requested 20 gigabytes, you will get 20 gigabytes because it will create it. So this, for example, would be your Kubernetes talking to AWS or to Azure, to the API, and this API will then create magically in the cloud, somewhere on some server in the world, the perfect storage that you requested. The other type is the static one, the self-managed one. This is if you run Ceph, cluster, or NFS, or whatever you have by yourself. You just make it known to Kubernetes that you have a volume here with these and these and these and these properties. Kubernetes essentially says, all right, thank you for telling me, now I know that it exists, and keeps a list of them. And then it will just take from this list of storage of volumes that it knows, it will take one and it will essentially save the state which volume is connected to which pod. Okay? So that's the way that storage works. Now, question?
Yeah, I just had a question
Yes.
about the thin provisioning. So, in both cases, do we have the option to thin provision volumes?
Could you explain the difference between the two?
I mean, thin provisioning is just kind of like, yeah, I wanna have 20 gigs, but I give you now 10, and then when you need more, I give you more.
Mm-hmm.
For stick provisioning, I give you the whole 20 the same whenever you ask for it.
Okay. What's the difference in essence in the effect for the end user? Why would I want to have a thin provision?
If I need my storage beforehand, because the request time time for this thing might affect performance for performance applications?
Yeah.
Or
So, who of you has been using virtual machines? Shocking. When you are creating a virtual machine, you usually also have to say which hard drive it uses, right? So it puts an image somewhere, which is then the hard drive. Usually you have two options to do it then. Either you say, I want to have a 20 gigabyte file, which is provisioned beforehand, or you're calling it a dynamic storage or increased storage or whatever the technical the term for this specific vendor is, where you simply start up with a 1 kilobyte file, 1 kilobyte file or something like that, and as soon as your virtual machine is putting stuff in there, then this file is getting increased. Now the problem obviously is that if we have a steadily increasing file, then we have a lot of mapping between the image file, and the underlying hard drive. And this mapping is costing a lot of performance, so it degrades the performance. On the positive side, I can say, hey, I have 200 gigabytes, when in reality, you can have 200 gigabytes, I don't care, when in reality you don't have that much at the moment. The same can be done for Kubernetes as well, and to answer your point, this is something that the storage driver has to provide. Okay, there are storage providers that have this specific option to do that, but that also has to be obviously supported from the underlying storage mechanism itself. So on AWS, as far as I know, you're not able to do that. For example, they just provide the thick storage. For Cluster.fs, as far as I know, you also have thick storage, but I've seen an LVM driver that is essentially creating logical volumes. Everyone knows what LVM is? Linux?
Yep.
Okay. So on LVM essentially, and there you can say exactly that. You can say, okay, I want to have a thinly provisioned one, for example.
You can use on AWS EFS, which is growing.
It's growing as well, okay?
yeah,
Okay. But that's not a block storage as far as I know, but an object storage, is it?
NFS.
file storage.
File storage.
NFS is file storage.
It's block storage? Okay, didn't know that. Okay, great.
And one advantage is you pay what you use.
Obviously, yeah.
Instead of EBS, which you pay what you want,
Mm-hmm.
what you claim.
Yeah, okay, so
Makes
it's,
a difference.
and I think I would guess that from a speed perspective, from a performance perspective, it's
Same.
the same, right?
Yeah.
Yeah, okay. So under the notes, they
Last
essentially,
price, much faster.
okay.
Speed increases with file and size.
All right.
Lars, one question also on this side.
Yes.
Just, do you happen to know if there's something like copy and write available?
Copy and write is also a driver question, as far as I know.
Okay.
Okay, so again, it's something that the driver has to support. And this is what I said about, for example, the Cluster.fs. In Cluster.fs, it has to be supported from the underlying storage. So you have to configure the storage in a way that it actually supports that. And the driver itself that connects to it. For Cluster.fs, as far as I know, it is the default with you when you're using KKT. But I'm not sure about that.
It should be exposed also in the storage class, right? Somehow. These options like copy on write or thin or thick. I haven't looked at it personally.
That depends on the driver. So you can have storage classes. So a storage class is a storage class is essentially a way to define different types of storage. So for example, in my cluster, I have 3 nodes. All of the nodes have an SSD and a normal hard drive. SSD is obviously faster, as in contrast to the normal hard drives. So I have 2 storage classes. One is fast, which just takes the SSDs as a backend, and one is called slow, which takes the normal one. So I can expose, or let's say I can group different properties into so-called storage classes, And when a volume is requested through a claim, then you can choose a storage class and therefore then choose, for example, options like that. But again, it's just a grouping. So if the underlying storage mechanism simply doesn't give an option to differentiate between copy on write or not doing copy on write, then yeah. All right. More questions?
In case of a like a storage option that is available on several hosts in the cluster, how is the replication also handled in this model, or is it being done by the abstraction layer, or how does Kubernetes, for example, handle the case when you want to mount into different containers that are on different hosts, for example?
Okay, those are two different things. So first of all, as in terms of replication, Kubernetes doesn't care. That's things that the storage providers have to say. So in my case, for example, with the storage classes, I actually have three different slow classes. Slow 1, slow 2, and slow 3, which essentially says, okay, do I want to have it replicated on just one node, so no replication at all? Do I want to have it on 2 nodes or on 3 nodes? As an example. So Kubernetes doesn't care about that. As for mounting volumes into different pods, and on pods that are on different nodes as well. So if you have node A and node B, right? The question of if a pod or if a volume can be mounted from one node or from 2 nodes is actually something that the, again, storage provider can tell what its capabilities are. So, I have an example. Essentially, you can have, there's a list on the homepage, they have a table there which tells you what driver has which capabilities. The GlassStuffS and Hikiti have all 3, so you can also have, like if the storage is in reality running down here, you can just mount it from that specific part, because everything is going over network there.
I think there's also Scale.io, I heard a long time ago, which offers this replication option. It's a driver.
Yeah.
It's also offered the replication option with pods from different places because it's backed up by other storage like vPlex and so.
Yeah. So funny enough, the Min.io as well as GlassStuffS and as far as I know also Ceph actually run their own processes. So every time that you create a volume or something like a storage volume up here, a PV, then what you're actually doing is running or spawning a new daemon that is then having its own options, has its own endpoint on the network, and if a pod is talking to the storage class, doesn't matter where it runs, if it runs on the same node or on another node, then it'll just use any of that, which obviously means that the more volumes that you have, every time you're starting a new process, so if you have 100 volumes, then you can be pretty sure that your RAM is simply killed with processes for storage. So yeah. Okay. Then let's talk about create your own. If you want to really write your own. It's a pretty daring task, and at least I thought so, until I actually had a look at them. Flex volumes have been in Kubernetes since version 1.2. Anyone who has been writing their own flex volume yet? Okay, me neither. I actually wanted to write one for the specific meetup, and I had like 8 weeks to do so. Unfortunately, I'm currently building a house with my family, and I was on vacation, and I have 3 kids, and I have mouths to feed, and I have 2 employees, and unfortunately, I wasn't able to write one by myself. But at least I checked what to do with it, and I found out that it's freaking easy, supposedly. Okay, so please, everything that you see here now, footnote, secondary opinions, no primary knowledge, okay? So, it's been available since 1.2, and it took 6 minor versions, which in Kubernetes years is like ages of the universe, since it reached stable in 1.8. And the next technology, namely CSI, was coming in 1.9. So essentially they said, okay, now it's stable, let's move to the next one and do all the things that we learned from flex volumes that are a bad idea. Cool. Flex volumes are actually used under the hood by most non-native storage plugins, so everything that is not in the tree in Kubernetes itself are using flex volumes under the hood. There are 2 alternatives to do that. One is to use custom resource definitions and providing your own operator and so on and so forth. This is essentially what Rook is doing now. And the next big thing that is coming our way is the Container Storage Interface, or CSI, which I will talk about in a minute, or more like 5. The installation is quite easy. You write a script. You make sure through magic that this script is presented on all nodes, and you just put it essentially in there and it will be loaded automatically. No restart necessary. What do you need to implement? There is essentially 7 functions. The init function, which can also be empty. It is called when the volume is, when the plugin itself is initialized. You have to have an attach function, which attaches a volume to the host. So it's essentially doing this connection. There is obviously a reverse of that, which is called the detach. After we've attached it, we have a function to mount it into a container. So after this connection has been made and the volume is available to the host, then when the pod is being activated, then obviously the volume has to go there somewhere. This is what the mount and unmount function are. The last 2 functions are just 2 convenience functions, wait for attach and is attached, because with dynamic provisioning it might take a while until the volume is actually present and until it can be connected to the host. That is essentially everything that you need to do. And you can even throw away a few of them. Ah, great, okay. It shows it there. I didn't see it on this screen. This is an example file. This is an LVM example, and as you can see, it's written in Bash. So one of those high-level languages that are really, really, really hard to maintain. At the end, we can see, let's take the first option. The option is called init. And as you can see, all it does, it just returns the JSON which says, okay, I'm here. And down here we have the typical bash subcommand select query thingy, which is just calling the appropriate functions. Let's have a look at the first one, which is called attach. We will not go through everything, but so what does the attach do? As you can see, the interface that the flex volumes are using is always JSON. So as long as you understand JSON, then you can write your own flex volume, because all you're getting is some JSON parameters through this function itself. It's even at the top in the function call. As you can see here, attach JSON parameters and the node name. That is the signature of this function. And if we have a look at it itself, what it does is it uses JQ. JQ is a very, very little handy tool if you haven't used it yet and need to have something to work with JSON, then JQ is your friend. And it checks if this specific device is present. If it's not present, then it will say, okay, a value that this volume that was requested doesn't exist, and exits with a 1. And if it does exist, then it just says, okay, volume is already there. So quite easy to do. And the rest of the functions are not really that much harder. So writing your own flex volume plugin is actually very, very, very fast. What is the future? The future is the container storage interface. The container storage interface has been in beta since version 1.10, and the new thing is it's a joint effort of different cloud providers. So it's not only Kubernetes, it's also Mesos and yeah.
I'm sorry, version 1.10 of Docker?
Of Kubernetes, I'm sorry.
Of what?
Kubernetes.
Oh, okay.
One question to the flexible node.
Yes.
Do you need to implement your own storage class there for as well, or is it possible to match these two?
Yes, you can. I jumped over that step. The usage of it is essentially the same as with the other one. You are able to also provision something dynamically if you want to, but you have to do it like under the hood. So if we go back, then you would also be able to, if in the attach function, I mean, you can also create storage if you want to. But this specific kind of provisioning is not really endorsed. So FlexWorms weren't really meant to do that. They're usually just the connection class after the static volume has been magically created somewhere out of it. All right, thanks. Now with the CSI, we're getting a lot of new stuff. It's the joint effort. The problem until now was that vendors that created something or wanted to have their own plugin provider, they usually put that into the Kubernetes source tree itself. So it was in tree essentially. But that also meant that if there were some bugs in there and they wanted to fix those bugs, they had to wait until the next version release was there. Then the driver installation, as you have seen previously, we need root access to the nodes, which is a big no-go if you have shared nodes or if you don't want that for security purposes or any other things that you can think of.
You can make your own images.
Sorry?
You can make your own images and spin up the nodes from them.
In theory, yes, but there are some parts where it's, I mean, the security part of Kubernetes is like 2 other talks by themselves, and this specific part is hard by itself already. So there are certain situations where you simply cannot do that on certain business models. The next problem is obviously, well, if we're using LVM, for example, for storage, and then we obviously have to make sure that LVM is actually installed, so we have this dependency problem on external dependencies. And since it's really coupled to the Kubernetes stuff, the kubelet, for example, if you deliver some things back or you don't answer or you have some other undefined behavior, then you can really crash your own cluster, which is really a bad thing. So to mitigate those problems, the CSI only allows out of tree coding, so all of these things are now out of the usual Kubernetes sources. The deployment is done via Kubernetes native methods, so we are just running pods, essentially. It still requires privilege mode for containers. That is something that has to be done. And it's using the Google, what's it called, global remote procedure call? I think it's global. The G is for global, I think. It's just a coincidence that it has been developed. Very sure it's global, never Google. Okay, so what do we have to do to write those? Well, there are 3 different interfaces now. Interface number 1 is a controller. The controller essentially orchestrates the volumes. In other words, it's that part. Then we have nodes. The nodes, or this node daemon, this node interface has to run on every specific node itself, and it handles essentially everything below that line. So which pods are getting which volumes and so on and so forth. Both have to implement an identity interface, which is simply a thing saying, okay, what are the capabilities of the endpoint that you're currently talking to? Okay? So it looks a bit like this. We have gRPC as an endpoint. Kubernetes is talking to the endpoint, and each endpoint has to provide an identity. Yes, I've already seen that. You don't have to remind me. Okay. So here's a slide. Here's a slide. And here's a slide. The sources are there. Have a look at them. How to deploy them? As I said, node service and controller service. The node service has to run on all nodes, so we take a daemon set. The controller service itself is one endpoint, so we can have a stateful set so that it doesn't change the address all the time. And in order to talk to Kubernetes, we have another layer of abstraction. The abstractions are the driver register. So the driver register is essentially the sidecar of Kubernetes, where the new drivers attach to. So they say, okay, I'm here, I have these and these capabilities, and you can talk to me to get volumes. And we have two different programs, another two sidecars, the external attacher and the external provisioner, which then talk to the node service or the controller service. The reason why we have these sidecars now is just for convenience, and that Kubernetes, that we can handle everything in pods, and that we don't have to have access to the underlying host system. Okay? So this is how it looks like. We have the node interface on each node. We have a controller interface. There's actually a mistake in here. Obviously, we need a node interface here as well. I forgot that one. And then on each node, we have the driver register, which is the Kubernetes part of talking to the node, and the controller node that, as I said, organizes what volumes are available and who's talking to whom. We obviously just need one. And we have two things there, the external provisioner and the external attacher, that just take up the essential functions. What do we do with that? Flex volumes are dead. CSI is the future, trademark. And CSI are not that more powerful than flex volumes. They just do essentially the same, but now with gRPC, 3 sidecars, and a lot of different things. So essentially we got the same, but with a lot more complexity. And we have obviously a lot higher development effort because now we have to talk gRPC. We can't simply have this, in best case, a bash script that does everything for us. But why is it still great that we have that? Well, the idea behind this joint effort is that anyone who wants, or any company that wants to provide a solution, any entity that wants to provide a solution, now only has to write all of their connection stuff once. One common interface. And then it can be used by Kubernetes, it can be used by Mesos, it can be used by OpenStack, doesn't matter. As long as they speak CSI, they are ready to go. This obviously is a huge benefit for all of the providers of storage, and this hopefully leads to a unified and therefore high quality or better services in the end, or better drivers. Yes?
So, I'm sorry, maybe I missed a lot of this. So what really is the benefit if we're hopeful that it leads to a unified and higher quality, right?
Yes.
It does add another layer of complexity.
Yes, it does. And we have to have gRPC.
And I think maybe the benefit here is that it's not in-tree anymore, it's like output tree, as you said, and then you have the option to decouple it from the Kubernetes source code, like the networking plugin or anything. You want to implement this microservices model. So anyone can just write some code in any language which satisfies an interface or a contract, and then plug it into Kubernetes and it works. It adds complexity. The only complexity is that this common interface is like the gRPC, because this is the communication language between these two, all these two components. So this is the only complexity in my point of view.
Yeah.
But you get a lot of benefits, definitely. Yeah.
And one of the biggest benefits is simply that it's being deployed with Kubernetes methods by itself. It's just another pod. And if the pod misbehaves, well, it's stateless. Kick it and restart it. Who cares?
Gotcha.
So those are actually a lot of benefits.
I think you mentioned that you cannot crash your kubelet.
Sorry?
The thing that you mentioned that you cannot crash your kubelet.
Yes, obviously.
That's kind of a
Pod is misbehaving, well, it has resource limits, and if Kubernetes says that it's unhealthy, it will just restart it. So that's a good thing that Kubernetes is, that it's not so tightly integrated into Kubernetes that it can actually crash it.
I also want to add that it's like safer for the kubelet, because if you like patch the kubelet in the style, in the old style, yeah, you rely on the system scan correctly, and so you not a whole node will go down, only a few parts of the pods going down, and you get a more secure way to operate it.
Yes, in that sense, it's actually secure.
Installation to do.
Yeah. And again, you in certain scenarios, if your cloud provider, if you don't host it by yourself, and if your cloud provider simply doesn't allow direct access to the underlying nodes, as you, for example, get with AKS, if you use the Azure Kubernetes service, as far as I know, you don't get root access to the underlying nodes.
Still get, but it's discontinued.
Okay.
Question. If flag volumes covers 90% of my use cases, why would I use CSI? Even so, I have the reliability response. If I say, okay, this is data I can forget, I don't need it.
So for my specific use case, I'm completely with you. I have self-hosted bare metal Kubernetes clusters. I have root access to all of my stuff, and I will not get this complexity into my system at the moment. If I, for whatever reason, need to have external storage and want to drive my own, then I will use flex volumes for the moment. But if you have like 4 big, huge companies who say CSI is the future, if you use flex volumes, then die. Die. Then, okay, flex volumes will be deprecated in the near future.
But in the end, it doesn't really matter, because you just take the drivers that are there. If you need a driver for X, Y, Z storage solution, you don't care if it's a flex volume or whatever driver. Just take whatever somebody basically.
Yes, there's actually a bridge. There's actually a bridge. So all of the flex volumes that are working right now, there will be a bridge between CSI and flex volumes, so that you can just plug the flex volume into the CSI layer, and then you're good to go. So still you have the added complexity. And we already have a really, really, really big complexity. I mean, just imagine what we've reached with Kubernetes and everything in the past 10 years, with Docker and all of this stuff. I mean, I'm currently running Kubernetes 1.8 on my cluster, I think. And now we have Kubernetes 1.11, I think, in stable. And they already added so many options that I'm overwhelmed. I'm not up to date. And it's been like 6 months or something like that. So the speed and the way of abstraction layer that we are currently having is already insane. And well, now we have another one. So.
Maybe the question is a bit silly, but why would you do files anyway? Why would you do storage if you could also use a database? One of the many thousands you have.
Absolutely, but it really depends on your usage model. So for example, usually what I want to have in best case scenario, which is what we, for example, achieved at Haufe Lexware. It took 18 months, but we achieved essentially a disaster recovery. That means that you start from zero. So everything's dead, we start from zero. And we want to redeploy everything. The cluster, the databases, all the data, all the pods, all the dependencies, all the services, everything for the biggest product of Haufe Lexware, which is accountable for, I don't know, a third of their yearly income. And we were at 90 minutes for that. That's essentially the way that you want to go. And how you achieve that, if you achieve that by then having your file storage somewhere on NFS, or if you say, well, fuck it, we'll simply say, okay, we run Kubernetes for the nodes, but storage is something that Azure should have, why not? As long as you achieve what you want to achieve or what your requirements are, then you're fine to go. I'm one of those people that really cling to, I want to know what is happening. I simply don't trust the other people. I want to dive into that thing. I want to read the source. Okay, I'm a little bit paranoid. Okay, let's just say it like that. And for me, it's really important that I know what my storage is doing under the hood. This is why this is not an option for me, and this is why somehow I like the idea that I'm able to write my own flex volume, and that I can write my own CSI, or that I can run my own Ceph cluster with book under the hood.
This is also why you have an upgraded.
No, that's more of, as I mentioned, house, kids, job, employees, and other stuff. Sorry? Yeah, but they're working on other projects so that I have time with my family and don't work 60 hours a week. Okay, enough from me. If we have more discussion, then we can do that, but we can do that for the next topic, which is pizza time, okay?